Hello all, thanks for coming. So my name is Gema, which is like the Spanish translation from a gem. I like to observe what is around me, and somehow I feel motivated by overcoming the challenges that may come in my way. I believe that giving is the way to go. And what brings me here and makes me do what I do is learning every day. And of course, enjoying what I'm doing. I'm an open source believer, and I have participated with several open source projects, such as with OpenNASA, DeepMind for StarCraft, and DVC. I like open source, and I firmly believe in that. And now I'm also part of Icertis, which is a multinational consultancy firm in Spain. And yeah, a little bit about me. So this is a journey about transformations, about how changing the way we understand the context in a sequence has an irreversible impact in the machine learning world. This is a journey about change, growth, and evolution of the field, and a shared common exploration about how to use an open source tool for develop better machine learning experiments. So why are we going to talk about transformers? So there has been this kind of paradigm shift with three main kind of giant rocks: the explosion of data, the huge amount of compute power, and new neural network architectures that had allowed us to do something different. So we are going to talk about transformers because its neural network architecture that is extremely versatile. It overcomes the state of the art in terms of speed and accuracy. And most of all, if there is another reason why we are talking about this is because it's okay, the core technology under the hood of the GPT models, but this neural network architecture has extremely aged well. So before we have these machine learning scenarios and subfields all across its own vast lands, and each one of the fields use its own machine learning and neural network architectures. So for computer vision, for example, we have the convolution neural networks. We have operation with these matrices to extract information. NLP use memory-based architecture, such as recurrent neural networks or long short-term memory. And in the case of translation, we had sequence-to-sequence models. And then what happened is that over the time, transformers got into each one of those subfields and started to add a significant value to them. Today, we're going to focus in one of the lands, which is translation, and we are going to see a little bit what happens under the hood. But hey, what is this useful for? So this is useful for the tasks that ultimately are involved with translation, but in an automation scenario. So we are talking, for example, if we want to internationalize a website, or even in the video game industries, when we want to translate all the things and adapt them to another culture, we can use translation for that. So yeah, we're talking about translation, but in a faster and automatic way. But how does this work? So first, in a high level, we can understand this as a black box that transforms one sequence into another sequence that can or cannot be of the same length. Nice. So we have an input, in this case, destruir el anillo, which is destroy the ring, but in Spanish. And it's the input that we are going to feed into the transformer architecture. And the output is going to be the translated sentence. But if we go down a little bit more, we found two main submodels, the encoder and the decoder. So what is going to happen is the encoder is going to take that sentence, that sequence, and it's going to transform it into a numerical representation. That is going to be the input of the decoder. And that decoder is going to map that numerical representation into another sentence. But if we go even one level down, we can find that the encoder has what we call the self-attention mechanism that is connected to a neural network, a standard neural network with its weight and biases. So we are going to use like this self-attention mechanism to learn. In the case of the decoder, if we go one level down, we also find the same thing, self-attention mechanism, then kind of like this recursive call again to an encoder-decoder attention scenario, and another feed-forward network. Nice. Let's recap. So transformers transform one sequence into one sentence into another sentence that might or might not be of the same length. This transformer architecture has like two main submodels, the encoder and the decoder. And there is like kind of like a tricky, weirdly magic that we call the self-attention mechanism. So yeah, this attention mechanism is kind of like a key innovative thing because like neural networks architecture have been kind of like using other mechanisms that can be similar, but it's kind of like a new approach. So let's pay attention to attention. So in a sentence, we can say that what attention is going to do is going to look at the context when it's mapping to different sentences. So it's kind of like a data-dependent transformation that is going to look at the context in that sentence. What I want you to take from here is that attention is going to be able to look at like that two sentences and map the relationship in between them with that score. What does it mean? It means that we have like a sentence, destroy the ring, and that sentence is going to have like a relationship with its translated one. But it's not only going to have like a one-to-one relationship, like I'm going to translate destroy into destruir, the verb. It's going to map like the relationship in between like all the elements of the sequence. So what does it mean? This means that at the end of the day, we will have like a matrix that it's going to map these relationships with a score in between the words. So we have destroy the ring, and then we have like the translated sentence. So destruir is like the verb that is like similar in Spanish for destroy. And it's going to have like this higher score because the relationship is more important. But it's also going to be related to the ring and the pronoun. The same happens with like different words. So we are not only mapping like one word to the rest, but like creating like all this relationship. So at the end, we will have like a matrix that can map if there's a one-to-one relationship in between like the words. And it's going to create like different relationship in between verbs and in between verbs and names, verbs and pronouns. In this way, like the machine can understand that we are talking not only about one action, but one action related to something. But there is more. After attention comes self-attention. So what self-attention is trying to tell us is that, in this case, Aragon, is that one word doesn't belong to one position, but to all. And it's trying to rebuild the context in that sequence. So in attention, remember, we have talked about like this mapping relationship with a score in between two sentences. In self-attention, we are not going to do that. We're going to map in like the relationship in only one sentence. So let's look at this. Frodo is right, Gandalf. Let's go right into Moria. If we have a like look at this, we see that there is like a same word that is right? But it's talking about like different things. In the first one, we're talking about like a correctness. We're talking about like rigorousness, about Frodo being correct. In the second one, we're talking about direction. So what self-attention does in that sequence is allow the machine to see what in linguistics are called the homonyms, which is like what we have here. I don't want to go like a lot of like into mafia stuff, but whenever you are like a software engineer, a data scientist, or a data engineer, we have one thing in common: data structures. So what is going to happen is that we are going to decouple that sequence into a dictionary structure, and we are going to do the magic with a dot product. So yeah, but wait, there is more. The beast of many heads. So what multi-head self-attention, what it's going to do is going to parallelize and repeat this operation once and again and again and again and again. We had a lot so far, right? Attention, a mechanism that maps the relationship in between two sentences using scores. Yes? Self-attention. Self-attention is going to look only at one sequence. And multi-head self-attention, we're going to scale and do it like many times. I hope this is clear, and this is one of like the key ideas. So I'm going to repeat, because like repeat is key for learning, okay? So please, attention, we map relationships in between two sentences with a score, and the difference in between that and self-attention is that in self-attention we are only talking about one sequence. That allows us to see the magic of understanding context. And then we parallelize and parallelize and parallelize. So let's go back to our box, because at the end of the day we are building stuff. What we want is to translate and automate a task and solve a problem. So what we have is like a class. Here I'm using like TensorFlow. We instantiate a class in which we are going to have like a set of parameters. So the number of attention heads, remember that matrix that maps relationships in between two sequences. Here we're going to define and instantiate the number of times that this is going to happen. We're going to do this multi-head self-attention mechanism. And then we're going to use some stuff. So we will have like a neural network with its weight and biases, in which like we are going to connect our attention mechanism. So we need to define how this is going to work. And we're going to also like have like this vocabulary size that can be of one, depending on the data set that we are using, is going to be from one way or another. And then we might think, okay, so I have like the transformer box, I have my data set that is going to go from one language to another, and I have been training a model. And I have like some code there. But there is like this path that goes from Desire to Gondor or to the core moon. There is something that like machine learning models and the Lord of the Ring have like somehow have in common. So what happens, I have like had an hypothesis, and I have like kind of like code something, but how do I go to like the model that I need? And for that, we need to run like machine learning experiments. And we need to find the parameters that we want. We might want to do different feature engineering. And then, hopefully, going from a hypothesis, we will find our model. So we start prototyping, and what we use Jupyter notebooks. Jupyter notebooks are great for prototyping because they give us like, like super fast analytical mental model results in which we can validate that like each one of our steps it's the correct and it's the one that we want. But when we start running machine learning experiments, we start like having like some issues with the machine learning with the Jupyter notebook. So, what is one of them? So, okay, I have like my hypothesis, and then what I do a copy of the notebook. And then from that notebook, I change some hyperparameters. And then I run it again. I run it. And then I have like another hypothesis. And I make another copy of the notebook, and I change some stuff. But then maybe a business comes is like, okay, so we need to optimize the model for not doing like messy translation. So you have like to optimize for accuracy and maybe lower accuracy, but like the lower loss and higher accuracy. And then it's like, okay, I will do another copy of the notebook, and then I will search for the model that I want. And then a couple of days like goes by, and then you go back to your work, and you find like kind of like all of these notebooks. And unless you are kind of like going through an Excel, keeping a log, it's hard to remember which notebook was in what moment for the hypothesis that you wanted. On top of that, we have to train each notebook. So we change some parameters, and then say, okay, I'm going to change the number of attention heads, and here I'm going to change in the language, wherever. And then you can be training like multiple notebooks at once, right? Well, you can until you have like the dead kernel problem. I don't know if like this happens to you during like a grid search, for example, in a Jupyter notebook. So when we want to scale this experimentation scenario, Jupyter notebooks start like giving us like some issues, and start like making us like going slower. At the end of the day, there's a common thing. We have like some data. We are trying to find the mass model based on some metrics, and we have like some parameters. And what we are doing is iterating over those parameters to benchmark the metrics, to go to the parameters, to benchmark the metrics again. So yeah, there's this kind of like cycle, kind of like has this moment, right? And it's like, okay, what can we do? Can we find the Rivendell for machine learning? Can we find a place in which we can like run experiments, analyze them, even persist them, and be kind of like in a more orderly, happy scenario? I don't know how familiar you are with this, but there is like there are like some very famous open source tools. So for experiment tracking, there's a very famous state-of-the-art, that is MLflow. And DVC is another tool that has been used a lot of like for data versioning, but lately, it went at some point into a machine learning experimentation scenario. And then these tools, one of the good things of these tools is that they are set, built, improved, and used in the open source space. And if we think about like the open source for a while, in some sort, it's like a very scalable, inclusive, and even like a mature way to building software. You are there, you are seeing like how you can see like how things are done. You can find problems, and you can like propose solutions to the problems. You can find bugs. You can find things that are not working, and even you can request things that you would like for that to happen. So there's like some kind of like magic in this kind of like building in the open. And there's like an emergent figure in this scenario, that is the contributor role. So one of the things that I like about contributing on open source is that I can have I can consume and create. So when I have a problem, I search for it, and there's like a lot of probabilities that someone has faced that problem before. And it's giving me like, hey, I did this, and I tried that, and I tried like this and this and that. And if you scroll, you get the solution. That's a nice way to consume. I mean, it helps you, it saves you like a lot of time. You can also like propose. You can also like take like a problem that you might be facing, do some stuff, trying to solve that problem, or at least like find like a way to things have done. So when I think about like contributors in open source, for me it's like a little bit like the Frodo of the story. It's someone that voluntarily takes the burden of a ring and kind of like carries that way. So for this talk, and only for this talk, I have participated in like some of the things of the tool that I'm going to show you today. There was like a bug when getting started with the tool that you could only find if you upgraded like the VSCode version and kind of like put it outside of the downloads folder. And yeah, the only one thing about like indexing that error. So if any of you guys want to test that and face that error, if you search it, you know, this would save you some time. The second issue is like the participation of the onboarding, in the onboarding. I mean, when these people, I mean, when you're building like a tool or you're building something, sometimes like you lose perspective because like you are looking at the same things over and over again. And participate in something like onboarding and how a new user is going to see the tool when knows nothing about that, it also saves time. So hopefully this saves time to things working. The third participation has been like finding a bug in one of the features, the smoothing features, which is like a feature that allows to the training curve to see them smooth. And when we think about this, and this is like a thing that I have to overcome myself during my journey in the open source, is that, hey, I'm a data scientist. I mean, you know, open source is about like developing features, writing documentation. I'm not a software engineer, therefore, I might not add like a significant value to an open source project. So there are machine learning projects that are built on the open, and that need that machine learning engineer or data scientist knowledge. This is like an example of that, in which like, okay, there is a problem with the smoothing feature that is displayed. Let's say, I mean, the smoothing feature doesn't make things harmonically put in there. And there was a thing because like the batch size, that like it's a parameter that like it's highly tied to generalization during training neural networks, and it's something that if you're training neural networks, you're going to iterate over the batch size. Creates like a series, like a lot of like continuous data points that at the end have an impact on how the smoothing feature is displayed. In fact, I mean, you don't have to know everything about like how things work to report a bug or solve the solution. And this is an example of that. So when I report a bug, I always try to say like, hey, this is kind of like not working. This is why I think this is a bug. And this is how, I don't know, I should fix it at. So what I was proposing is like, kind of like changing the range for smoothing and linearly interpolating in between values. In the end, like the team was researching for that, and they discovered that like iterating over like the exponential moving average was a better solution. But open source, okay, this is all great, right? We all learn. We are Frodo. We take the ring and we want to add value. But open source has its lights and its shadows. And I think it would be pretty hypocritical not to tell you and not to face this in an honest way. There's like a very famous and very good book that is called Building in Public by Nadia Ekbal, that talks about like how open source has evolved over the years. It's kind of like the good evolution, well aged from the cathedral and the bazaar. And Nadia talks in this book about like the emergent figures and the things and the things that are good and bad. So here, as a contributors, I mean, I think we have like kind of like the responsibility, both as a contributors and the players of the open source space, to do something and to avoid the broken model, because now the model is a little bit broken. We should avoid and at least be mindful about artificial marketing. When like people is trying to sell the open source tools and they are not kind of like being honest or about like things, we should be mindful that sometimes it's good to do start doing open source because you can see or you want to see how it's working with those people. And I don't think that it's like kind of like beneficial not to those companies to do something and like acknowledge that this and can be a tool for hiring. And you as a contributor, this can be a tool for finding a job. Maybe you start contributing and you discover that you don't want to work there, so you save people out of time. And yeah, there is like this kind of like also trap about like working for visibility, explore, and this stuff. And yeah, I think part of like this journey has its lights and its shadows, and it's something that we should be mindful about. There's always hope. I don't think that having like bad things, it means that we should leave open source behind. And this is like also like a calling for like the open source for the machine learning people outside. We're living an explosion, and machine learning and the open source is coming. And not having this conversation couldn't be kind of like leaving out like the elephant in the room. Yes, so yeah, I think there is hope for that, and we can find a more sustainable model. So with all that in mind, with these 3 issues found, and with this exploration of the tool, I'm not going to sell you stuff. What I'm going to do is I'm going to tell you about like the project that I did and what I found out. I'm going to tell you what I like about the tool and compare it to the tools that are out there. So what we are going to see is like the DVC open source extension for VSCode. What this thing does is basically you are coding, you have your ID in VSCode, and it transforms you into a machine learning experimentation platform. This tool for experiments is not as famous as others as MLflow. So MLflow has like proprietary code to define the pipeline. So if you are using MLflow, you have to actually import the library of like MLflow to define a pipeline there. And you have to change to their platform, to another UI, just like TensorFlow stuff, that is going to show you your experiments. Benefits about MLflow. Well, in my exploration, I think that MLflow gets like time to work is faster. I mean, if I have to prototype something, I have to start running experiments. There are like many examples out there. So so time to things working, it's faster in MLflow. However, DVC, what they propose is like to kind of like structure your code in a more agnostic way. And it's good because like it's kind of like more aligned with software best practices. So what you are building is like kind of like an artifact that is going to be in which you can scale your experiments faster. So that is one of the things that I like, that actually like you have to be agnostically structuring your code and creating like one scenario. One of the things that I don't like that much is that time to things working is like much more slower. So hopefully with this talk we can change a little bit that. whatever tool you might want to use, there is like this like meta-mental model behind all this. There is things that like whatever tool you choose, you have to do these things. You're going to produce like some experiments, okay? You're going to analyze them, and then, okay, I want to this, I'm going to choose this, I'm going to choose that based on better performance, but then I'm going to choose another one based on like the business question. And then at the end, you want to persist, because like hopefully you want to move this machine learning model into production. And also, I like when people explain to me things in a sentence. So what is this about? This is about 2 YAML files in a library. So with these 2 YAML files, what we are going to do is we are going to define a pipeline. And we are going to have like another YAML file in which we are going to define the parameters. And there's going to create a relationship in between them. And then we're going to use like one library only to run the plots. And this is something that I like very much. It's like, okay, this library is not going to be messing up with my pipeline. I'm going to use it like only to load the plots where I want to see them. So if I don't want to use the plots anymore or whatever, I just like can take it away. And what we're going to see in our VSCode extension is this. We're going to have like a table in which we are going to have like an input that are going to be the parameters that are going to be defined in that param.yaml file. And we're going to have the output that are going to be those metrics. And we're going to have the plots. The plots are important because like it allows us to dynamically benchmark how well we are doing. I don't know how you feel, but I've been using like TensorFlow like for a while since it was like a painful graph-oriented tool. And when I have to use TensorBoard, I have to open a console, launch a job, and then open TensorBoard, and then I have like this weirdly hardly hash that tell me about like the machine learning experiment, but I didn't know which one was. So one of the good things about this is that like I have my table with my experiment, with the color, with the name, and then I go to the plots, and I can easily see in my ID that things are there. And then it's like, okay, Gema, you told me like your ruminations about open source, and then you were talking about transformers like and translation, and now the tool. So why? What happens now? So the thing is that when we are using whatever tool we are using, we want to solve a problem. We have a research question, we have like a business question, whatever. So here in translation, where I'm like trying to find if there is like one transformer architecture to translate them all. Can I use the same attention heads for all languages? Is there a model to translate them all? Okay, I have like in TensorFlow, then I have like a lot of data sets that translate from Russian to English, from Spanish to Portuguese, and so on and so forth. Can I have like only one model in which like I can like put the stuff and then they are going to translate it into English? So this is when the machine learning kind of like things start to work. Okay, so now we're starting like a moment in which like what I'm going to do is like go through the tool, and hopefully if you use that tool, it can save you time to things working. So the first thing that we're going to see is how to organize this. So we have the DVC YAML. That is going to show some stages, the process that we are going to follow to train the thing. So we are loading, we are doing a tokenizer, we're doing embeddings, numerical representations, and we are going to train the creature. So what we have here is that we're going to define a command, a Python command, in which like I have orderly put my code, and we're going to define some parameters. These parameters, at the end of the day, will be something that will be useful for the future. So what I want you to take from here is that we are defining the parameters here that are going to be put it in a config file in our code. Okay, so we have like define the name, train transformer, define the command that we are going to launch, define the parameters, and some dependencies. We can define the metrics and the plots. That is basically calling to the library. So what I want you to take from this is that we are going to define this in the dvc.yaml. And then we're going to go to the params.yaml file. And what we are going to do in the params.yaml file is that we are going to instantiate the parameters. We're going to define that here in train transformers, we have the number of encoder layers, and here we're going to put 4. In the decoder, we're going to put 4, the dimensionality on the model, and so on and so forth. So the key idea here, and please bear with me, is that we define the things in the dvc.yaml file, and we instantiate them in the params.yaml file. This is magic. Why? Because like if I want to launch 100 experiments, then I only have to change the params.yaml file. Yes? Is this clear? Yeah? Nice. So yeah, what we see here is that we are creating a relationship in between two YAMLs, and in one YAML we define, and in the other YAML we instantiate. Okay. And then we go to the plots. Once we start training our artifact, what is going to be happening is that we are going to see, as we train, we are going to see it like training, and like the metrics that we want to track appear in live. This is like amazing if we want to, for example, like avoid this is great in case, for example, that we want to early stop the experiments that are actually not being trained well, which is like what is happening here, right? So what is happening here is that like I have launched like 3 experiments, and I can see that this experiment is getting better. So I can stop these ones and not being trained anymore. So the thing about like being like seeing things in live can actually be useful. By the way, we are trained like the transformer, and we can see here that we have like this binomial situation in between the accuracy and the loss, and we must see like the accuracy is going up and the loss is going down. The other thing that I like about this extension is like the sorting feature. So the sorting feature allows us to establish like some criteria of selecting the best machine learning experiment with the depend of like, I don't know, our stakeholder. So previously, just remember with our super notebooks, we have to train another notebook once like, I don't know, a business hypothesis come. But for example, like here, if we sort by higher accuracy and lower loss, we can select the best first model that like avoids overfitting. Or we can like use it for false positives or negatives. So yeah, here like the sorting feature has been proven useful, especially when your table is kind of like growing. And then we have like this kind of like kit-oriented scenario. Me as a data scientist, I don't know, I have like been like, I don't know, super, not skeptical, like fearful of Git. And first time like someone like explained to me what a Git rebase was like, what? But at the end, it's kind of like a way to structure structure things in software that, like data scientists, we should, if we want to get the machine learning models into production, we should have into account. And good news is that this tool allows us to sync with Git. So here, like the dynamics are that I have like my main branch, and then I have created these two kind of like branches depending on the language. So what we will do is like each kind of like branch will have like one language attached. And we will iterate, as we have been seeing, in the params.yaml file. This is amazing. I structure my code, I built a dvc.yaml file, and then I can use like 4 languages in each. I only have to change like the params YAML file, and then we iterate over like some parameters here, and depending on the type of languages, we will like change some things. So the exploration here has been attached to mostly the batch size. That it's like, you know, like how recurrent is going to be. Some functions are going to be updated. Therefore, it's going to be super impactful in generalization of the model. And the number and the attention heads, right? Like, can we use like the same attention for all the languages? And then here, like, we can select like the best experiments of each language and visualize them here. This is all, by the way, all the code here is in GitHub. If you please reach out if you have like any problems on reproducibility. If you're using Mac, there's like kind of like a turnaround with like one library that is TensorFlow text, and TensorFlow Metal has its things, but please reach out. But I want to share like a couple of insights that I have from here so far. So one insight is like Cyrillic-oriented languages at the end require more attention for translation. So when I was using like Latin ones, like Portuguese and Galician stuff, like the attention, the number of heads that I needed to have like better performance was lower than in Cyrillic-oriented languages. And yeah, I mean, I tested like the dimension. I was like testing the dimensionality of the model, and I was testing some stuff. But like for me, the batch size and the number of attention heads, and kind of like being iterating in between like those two parameters, was good enough for at least like setting like a first benchmark from this. So we are heading into the end of our journey, but I wanted to share some conclusions with you. So the first conclusion is that transformers transform everything. So we have like this neural network architecture that is highly based on the attention mechanism. Attention mechanism is changing the way we see and understand and ultimately process the context in a sequence. That's why like it's allows us to see context in a sentence differently. Besides that, attention has been extrapolated to other fields and have aged. This architecture has aged well. The second is that like we are like there's this explosion of the machine learning scenario. We need to be responsible from the open source perspective, and if we want to kind of like get into machine learning into the real world, we need to be faster and more agile with our experiments. And the third conclusion is like I like to be focused in screens, and like this extension can transform your ID, in this case like VSCode, into a machine learning experimentation platform. So yeah, here you can find like, this is my GitHub. You can find like all the things of the project there. I'm quite active in the open, so feel free to reach out. Thank you.